Hello everyone, I'm Yuchen Liu and my team member is Yudi Chen. Our research project is FEIT course chatbot. So let's see the demo first. Let's start with introduction. The first question is what is FEIT course chatbot? It is directed for prospective students in search of university to get into. And who benefits? Definitely the students. It is convenient for them to quickly acquire course information by talking to the chatbot rather than searching information online. The third one is what can the chatbot do? The chatbot is able to answer user queries regarding courses at UTS, including details of the course, such as duration, credit points, as well as answering queries regarding the structure of courses and subjects at UTS. As for the aim of this project is to address some limitations of the current chatbot and then enrich its functionality. Some trivial issues are about the course questions. For example, if a user asks a question that contains non-existent course code, the robot should remind the user that the course doesn't exist instead of no response. There are two main objects of our project. First is to solve the current issue by improving the code of actions.py. The second is extend the chatbot from bachelor's degree to cover master degree courses, especially for the master course in Faculty of Engineering and Information Technology. The course chatbot is based on the Rasa Conversational AI framework, which is used for building contextual assistance. The Rasa consists of two main modules, including the natural language understanding, which is called NLU, and the core. Specifically, the NLU understands the user's message by training the intent data and the core learns how to respond to user messages by training the story data.
Thank you, Chen. Hi everyone, my name is Yudi Chen. I'm another partner in this group. I will introduce the next section floor. In this section, you can see the image. It shows the brief components in a flow of a dialogue system. The LU or NLU, natural language understanding, on the top right is in charge of intent detection and slot filling. For instance, the input is, are there any action movies this weekend? The intent is requesting movies and the slot of category and data, date, action and weekend. And then DM deals with the process of backend, like selecting records from the database and selecting the corresponding actions. I asked NLG, natural language generation, converts this information to a human sentence. And next, we search for some existing systems. We found there are many existing systems like Dialogflow from Google and Amazon Lex developed by Amazon. They have powerful functions, but unfortunately they are not open source and free. Let's see the open source systems. For instance, Chatterbot is an empty paper in the beginning. Its performance of conversation is increased by storing the statement of each dialogue. With the increased number of inputs, the options are more and the accuracy is higher. Next, for our environment, we use the operation system Linux, because Yuchen and me used a different system. So we need an environmental software on account of 3. And of course, Python, the version is 3.7. And we use, finally, we use Rasa with SPACE. And the next part is a key section in our project. It is Rasa. By comparing existing systems we mentioned in before section, Rasa has various APIs and is easy to implement along with open source. And this image shows Rasa's structure. I will introduce it going through the sequence. After message in, interpreter transforms the message to a dictionary which contains the original text and intent and any entities. The following is the key part, checker, which checks the state of a conversation and receives the information of a new message. And policy selects the appropriate action. And finally, action makes the corresponding responses to the user. And next, in the program architecture, I will introduce some crucial files which compose the program. The first one is config.yml, is the configuration file defining the NLU and the core models. The messages are processed by a series of components which are executed one by one in a pipeline. The pre-trained embeddings space is one pipeline. It can replace the entities in a sentence if the sentences have the similar structure. For instance, the system can know the intent for get banana, even though the train data may be I want to buy grapes, because the banana and the grape are similar. Next stories defines some examples so that the chatbot can mimic a conversation by following the examples. And domain restricts the range of the services. These actions are the functions created by the developers themselves or ourselves. Yeah. And the final one is NLU, is the training data to understand the meaning of a message, including a set of sample sentences.
As for implementation part, there are 3 steps to install Rasa. The first step is install Rasa open source with spaCy by using the pipe command. Then we should download the medium-sized model for the English language version of spaCy. Finally, link the language model with spaCy. But the implementation process didn't go as well as we expected. We encountered 2 problems. The first problem happened when we tried to install spaCy together with Rasa. The process was killed by the system, which means that the system is out of memory to install. The solution is that we increased the memory size of the VMware virtual machine from 2 GB to 4 GB, and then the spaCy was installed successfully. The second error happened with downloading language model of spaCy automatically, which is by the command. The reason why it failed is that the remote connection to the source of the model is refused. So we tried the website of spaCy and got the link to the source code of English model on GitHub. We downloaded and linked the corresponding English model with the spaCy version, and the course chatbot can run. One of our main work is inserting master courses data of FEIT. The FEIT course chatbot reads the data from 4 CSV files: courses, items, relations, and alternative names. We collect a total number of 2,999 data from UTS handbook and insert into these 4 CSV files. The first file is course. This file records all the course information, including course numbers and names. And there are 26 courses in master course of FEIT. In items table, there are 5 kinds of majors or subjects. The first one is choice block. If a student selects a CBK to study, this student can choose any subject in this block and complete the credit points required, which is shown in the column D. 99 choice blocks have added to the items table. Second one, majors. Items with the prefix major. The number of subjects in majors is fixed. The student who chooses a major in is required to study all subjects in this major. 41 majors in FEIT added. The third one is sub-majors, which is similar to majors. Some majors may contain too many subjects and need to be divided into smaller pieces. So this is sub-majors. There are 21 sub-majors inserted into this table. STM means string. A string is the most important part of course. The string in a course represents the professional direction, and 94 of core strings in FEIT added. Subjects are the smallest units in the FEIT course structure. What students actually study are the subjects. There are 209 subjects in our faculty, and they are added into the items file. Each number in relations is a course or item. The numbers in column B belongs to the numbers in column A. All the direct relations between courses and items are written in this file, which is with a huge number of 2,478 relations inserted. This file preserves the alternative names of courses. In this way, the chatbot can answer the course information by entering the aliases or abbreviations of the courses.
Okay, now I introduce some functions we developed. As you see, they are extending the duration of a conversation process of non-existing courses and improving the sensitivity of master courses. Let's look at extending the duration of a conversation firstly. The chatbot had a little issue, which is stopping the conversation early by goodbye. As mentioned in program architecture section, the file storage store.md controls the templates of conversations. Therefore, this issue is solved by extending more actions in a story. And secondly, the system returns a code error if the name of the course doesn't exist. It will affect the user experience. So the resolution is tracking the given courses by traversing the list of courses. If the result is none, it just gives back a prompt and listed existing courses. Yeah, like the picture source. You can see the final result in the picture and in the demo. Finally, the chatbot aren't sensitivity to the names of master courses. Like the first image is also sorry I didn't recognize the input. The input is master ID. Yeah. But actually it can give the information of the course if using the course ID. So in short, the problem happened during NLU, so the result is solved by increasing more samples in NLU.md and stories.md. In conclusion, in this presentation, we introduce our objectives, the flow of dialogue systems, and the existing systems, and discuss the architecture of ROSA and our program. And besides, we describe the implementation, inserting data, and adding more functions. Thank you.